के बच्चों से पूछते हैं, वो बोलते हैं नहीं सर हमारे यहाँ तो कोई है नहीं, रीबा सर पता नहीं कौन है।
सर हम from Alalia.
हमको ये डरा रहे हैं बोल बोल के कि 20 फरवरी से उनका एग्जाम है।
So I think everybody will have it at the same time.
एवरीवन विल हैव एट सेम टाइम, ऐसा क्यों होगा?
Maybe. I don't know.
व्हाई? आई डोंट नो, ऐसा क्यों होगा भाई कि सबके एग्जाम साथ में ही हो? ये अभिनव, हाउ आर यू?
I'm fine, sir. How are you, sir?
आई एम गुड। अच्छा एक बात बताइए, यू आर इन इंडियन इंटरनेशनल स्कूल और अलालिया?
IISR, sir, Indian International.
रियाद?
Yes, sir, Riyadh.
नॉट अलालिया?
No, sir.
नॉट अलालिया। तो आपकी एग्जाम कब से है?
Sir, date नहीं दिया अभी तक.
देखिए, ओके फिर सी डेट नहीं दिया। ओके, योर सिलेबस इज ऑलमोस्ट कंप्लीट या फिर काफी कुछ रह रहा है?
In school, sir.
हाँ, इन स्कूल।
In physics, there are 2 chapters left. In chemistry, I think 3 are left. And bio का खत्म हो गया.
ओके, सो इट्स ऑलमोस्ट डन है ना? इट्स ऑलमोस्ट डन।
Yes, sir.
सो फेब तक वो करा ही देंगे हमको लगता है जहाँ तक। ओके फाइन, नो प्रॉब्लम। आई थिंक दे शुड लाइक एटलीस्ट दे शुड गिव 1 मंथ्स टाइम ना। इन जनरल ऐसे कब होता है अभी ना? व्हेन डिड लास्ट ईयर हुआ था एग्जाम 11th के लिए?
Yes, sir. Last year exam हुआ था 11th का.
तो कब था, कुछ आइडिया है आपको?
Yes, sir. February के second week से या third week से, sir. शायद.
अच्छा ओके। एंड रीबा आपके यहाँ तो फिर हो गया सिलेबस, आई थिंक सो, बिकॉज आई थिंक हिश्मा इज समवन हु इज इन अलालिया। हिश्मा है आपकी क्लास में कोई? यस रीबा?
Who, sir?
हिश्मा?
No, sir.
No, okay। and how much chapters are left in your school?
In physics, we have 2 chapters left. In chemistry, 2 chapters left. Biology, 2 chapters left.
अच्छा, केमिस्ट्री में those 2 chapters, what are those? SNP ना, I think
Yeah,
you said
SNP. SNP.
okay fine, chalo, no problem। so see, when we have different resonating structure now, so let me make one resonating structure of CH2 double bond, CH single bond, CH2 positive। okay, CH2 positive। now if I will make a resonating structure for this carbocation, then it is going to be CH2 single bond, CH single bond, CH2 and double bond here and a positive charge here। now as you can see, both of these structures are same, right? now when we have this type of resonating structure, that means the resonating structure 1 and the resonating structure 2, they both are identical, so we say that this is an example of identical resonance. It is an example of identical resonance। okay, now in this case you can say that both the structures, resonating structure 1 and the resonating structure 2, both are contributing to the resonance hybrid equally। CH2 CH, CH2 partial double bond, delta positive and delta positive, fine। now in this case you don't have to compare because both these structures are same, but you can have different structures। okay, you can have different structure। I will give you example, but first of all, it is right, if right rules for stability of resonating structures, rules for stability of resonating structures, the number 1 rule is a structure with more number of bonds if you will have more number of bonds, if the number of bonds is more number of bond, then more stable, this is the first thing that you will look in the resonating structure। if you have to compare 2 resonating structures, then you will count the number of bonds in each of them। if both are equal, then you will move to second step, but if one has more bonds than the other, then you will mark that one as more stable। but if you have both the number of bonds equal, then you will say that the neutral one is more stable than the charged one. If there is a resonating structure which is neutral, that will be more stable than the one which is having some charge, plus and minus both charges. Okay, if an atom has a plus or minus charge. Third is negative charge is stable on more electronegative atom. That means either fluorine, oxygen, or nitrogen. Okay, so these are, or any halogen also. So these are the electronegative element. So negative charge, if it is on fluorine, oxygen, and nitrogen, then it will be more stable rather than on a positive charge, rather than on a electropositive element such as carbon. It's more stable on more electronegative atom than on carbon or other less electronegative atom. Similarly, if a positive charge is unstable on electronegative atom, okay, you can also write the same thing. I mean, it means the same thing. You can involve that in the third point only. If negative charge is stable on the electronegative atom, that means positive charge is unstable on electronegative atom. Right. The next one, that is like charges. Like charges should be far apart. For stability, should be far apart. Unlike charges are more stable when in vicinity. Vicinity means when they are near. Okay. So these are the 4 rules that you have to remember in order to tell about the relative stability of different resonating structures. So write these 4. Let me know if you're done. I will put up a question. Compare the relative stability of the following resonating structures. Are you done with the 4 points? Please let me know. Okay, Sarah is done. What about others? Umar, Abdullah, Reba, Abhinav. Raise your hand if you're done. Okay, thank you. Compare the relative stability of the following resonating structures. So the A is okay, so the bond has moved on the oxygen atom. Yeah. So write this down. Don't start solving. I will ask you some questions. Okay. Then only you will start. Yes. Have you written the question? Yes or no? All of you?
Yes, sir.
Okay. Now for the A, all of you will send me in chat the number of bonds. For A, how many bonds are there? Okay, you will count all the bonds. Then in A, how many are there? B, C, D. You can just separate that by comma. Count the number of bonds that you can see. Send me in chat now what happened. जल्दी से काउंट करके आप लोग भेजिए, है ना? Yes. You can take a screenshot, Mohammed Umar. Yeah. Yes, Sarah. Correct. What happened, others? Reba, Abhinav. Yes, Reba, how many bonds are there in the A structure? How many? I did not hear that. Can you repeat that? Yes, Reba.
5 bonds.
5 bonds. So why did you not send me in chat, Reba? What happened? You were counting?
Sir, I sent it to Learnivio. I thought I sent it to you.
Oh, nahi. Achha. What about the B1? Tell me. Abhinav? Abhinav, B में बताइए कितने हैं bonds?
4, sir.
4. Umar Abdullah, you tell me in 5, in the C structure, how many bonds are there? Not there. Okay. 5. Okay. Muhammad Umar, can you count and tell me how many bonds are there in D structure?
4.
4 bonds. Okay. Now, when I look at this, then I cannot decide which of them is the most stable. I have a tie between structure A and structure C. Both of them are what? Both of them are having 5 bonds. Both of them are having 5 bonds. And I will see the neutrality and the charge, right? Whether it is neutral or it is charged. The neutral will be more stable, charge will be less stable, right? So first of all, I will compare between A and C. So now you guys tell me, A is neutral, or does any atom of A has charge? Yes. Is there any atom which has charge in A?
No, sir.
No. So this is neutral. Then I will move directly to C because I need to just compare A and C right now. Now you tell me, in the fifth one, I'm saying the C structure, it is charged or it is neutral? Is there any atom? Hey, is there any atom which is charged in structure C?
Yes, sir.
Yeah, so we have to look at whether the molecule has any atom which has a charge. So this will be charged. Now from this two I can compare and I can say that A is the most stable. Yes or no, guys? We have A which is most stable, followed by C. Why? Because C has more bonds than the others. Now I need to compare B and D. So for comparing B and D, I cannot use the charge criteria because both are charged. Yes or no?
Yes, sir.
Both are charged, right? Now I have to look at the negative charge. Where is the negative charge? Okay, where is the negative charge? Now I don't need to compare. I don't need to write anything about A because we have already said that A is most stable. Now, in this particular B structure, the negative charge is on which atom? The negative charge is on which atom?
Oxygen.
Oxygen, right? It is on oxygen. And I don't need to compare this structure. Now you tell me, in the D structure, the negative charge is on which atom? Negative charge is on carbon. Okay, now we know that oxygen is more electronegative than carbon, and that is why B will be more stable than D, because the negative charge on the electronegative atom is more stable. This will be followed by B, and this will be followed by D, which will be the least stable. Okay, write this down. Let me know if you're done. All of you done?
Done, sir.
Okay. Write the next topic, that is mesomeric effect. Mesomeric effect. First of all, we will write the statement, then we will understand what is mesomeric effect. Okay, please write with me. Shifting of, another way to say shifting, or you can write displacement. Shifting, displacement, movement, anything. Okay, of pi electrons. Pi electrons or lone pair electrons or lone pair electrons towards or away from a substituent group. Okay. Now, if I will have a structure as CH2 double bond, CH single bond, OH. This oxygen will have a lone pair. The electron movement in this case via resonance will be like this, right? Now, in this case, I can say that the CH2 will be getting a negative charge, a single bond CH, and there will be a double bond OH. Now I can say that this OH is our functional group, right? It is the functional group, and the electrons are moving, and the electrons, they are moving away from the OH group. So this is, I can say that it is in a sense donating electron to the carbon chain. It is donating electron to the carbon chain. This is an example of electron donation. Electron donation. You can see electron donation from the OH group, right? The OH group. And this, we say that OH is a electron donating group, okay? Or it shows plus M effect. As an inductive effect, if the substituent or the group, it is giving electron to the carbon chain, then we said that it is plus I, and in this case we will say it is plus M. Similarly, you can have some other case where you have CH2 double bond CH single bond C H double bond oxygen, right? In this case, what is going to happen? You can directly write as a structure like this: CH2 single bond CH double bond CH single bond O negative, and here you will have a positive charge. In this case, you can see that this carbonyl group, right? This carbonyl group, it is taking up the electron. The electron movement is towards the functional group, and that is why this will be a case where the functional group here, it is taking electron from the carbon chain. So this is a case of electron withdrawal. This is a case of electron withdrawal by CHO group, and this is electron withdrawing group, or it is a minus M effect, okay? Write this down. Let me know if you're done. About mesomeric effect. Mesomeric effect is same as the inductive effect, but see, in inductive effect, the main criteria was electronegativity of the atom. If the electronegativity was higher than carbon or hydrogen, then the group was taking up electrons from the carbon chain. If the electronegativity was lower, it was giving electron to the carbon chain. Now, in this case, the criteria is resonance. How the resonance is happening? Resonance is our guide for where the electrons are going, whether it is going away from the carbon chain or towards the carbon chain from the substituent atom or group, that we have to see. And it can be also classified into two types, plus M and minus M. We will understand what is plus M and minus M, but for that we need to understand a few very small concepts, and we need to practice on that. Then you will be easily telling which is a minus M group and which is a plus M group. Let me know if you're done. Okay, is there anyone who's still writing? No? Okay. Now, one thing that you have to note, all mesomeric effect All mesomeric effect are resonance, but not all resonance are mesomeric effect. Okay, an example for this will be if you have butane, if you have but 1,2-diene. In this case, what is going to happen? You can see this can move here, and this will go to this carbon atom, right? And you will get negative charge here, a positive charge here. Obviously, this is a resonance. I think this is an example of resonance, but there is no mesomeric effect here. Okay, this is an example of resonance, but no mesomeric effect. Resonance, but not mesomeric. Okay. Okay. Now we need to understand the minus M and the plus M. For that, you need to understand about and you need to identify the key atom. What is key atom? Okay. Now, key atom is not a concept of organic chemistry, but it helps you in identifying the minus M and the plus M. Okay, minus M and the plus M. Please write the atom of the functional group, the atom of functional group or substituent that is directly attached the atom of functional group or substituent that is directly attached to the carbon chain or ring to the carbon chain or ring. Okay, that is the key atom. That will be the key atom. First of all, you will identify the functional group. Then in that functional group, you will identify the key atom. So write a question. Identify the key atom in following. Identify the key atom in following. First of all, identify the functional group, then only identify the key atom. Okay, otherwise you will do mistake. First of all, identify the functional group. In that functional group, there will be a key atom. Write this down. Let me know if you're done. Yes, I hope you guys have identified. So for the first structure, please turn the mic on and tell me what is the functional group in the first structure, guys? What is the functional group?
Pole.
Yeah, नहीं अब तो nomenclature नहीं कर रहे हैं ना. So can you please tell them in terms of atoms, like OH, NO2, ऐसे. हाँ, okay, thank you. Okay. अरे all अब मत बोलिए all please, okay. Like we are done with nomenclature. That is only helpful in nomenclature. Now you have to tell me whether it is an alcohol or it is OH or CHO, OH or CHO, whatever you see. You say that. Now tell me the key atom. What will be the key atom in OH? O will be the key atom. Okay, fine, very good. This is the key atom. In the second structure, tell me what is the functional group?
O and H.
नहीं, functional group तो ऐसे. Did we write any functional group like that? No, na. The functional group is aldehyde, na. Tell me.
Yes, sir.
So aldehyde में CHO होता है ना.
Yes, sir.
So this is our functional group. Okay, this is our functional group. What will be the key atom now? This carbon will be the key atom. Correct? Because this carbon is connected
Yes,
to the
sir.
carbon chain. I have not written here main chain. Okay, please remember that. Not main chain, carbon chain. Or functional group. Now in this structure, we'll have nitrogen as the key atom. We'll have nitrogen as the key atom. Again, in NO2, what will be the key atom here? What is the key atom here?
Nitrogen.
Nitrogen. Okay. Now in this, the ketonic group, CO group, right? CO group is the functional group. This carbon will be our key atom. Similarly here, this aldehyde is our functional group. Then again, this carbon is going to be our key atom. Okay. Now in this case, we have carboxylic acid, COOH. In this COOH, this carbon is going to be our key atom. Okay. Then we have Cl. In this case, we don't have any other atom. That is why this Cl will be our key atom. And then this nitrile, we will have carbon as the key atom. Okay. So tell me, guys, any problem
No,
in
sir.
identifying the key atom? No problem, na?
No,
problem.
sir.
Okay. So please write this down. I hope you have written this down. Okay, just mark them. What is the key atom? Those who have not written. Done? Now you write here. How to identify plus M and minus M. Okay. So first of all, write minus M groups. What are minus M group? the groups that withdraw electron from carbon chain, those are called minus M group. Okay, so what is the, how can we identify the minus M group? The first identification is that if you have the key atom, right? Key atom attached to more electronegative element, more electronegative atom via multiple bond, then it is going to be minus M. Or simply sometimes what you will see, key atom has positive charge. Okay, so if the key atom, it is a charged molecule and it has a positive charge, then also it will be electron pulling, it will show an electron pulling effect. That means it will be a minus M group. Okay, it will be a minus M group. I hope you guys can identify. Let us write about my plus M now. So whenever you see a group, first of all, you will identify whether it is minus M or not. If it is not minus M, then you will move forward and tell whether it is plus M. But first of all, please confirm if it is minus M or not. Plus M group. So what is the specialty of plus M group? The specialty of plus M group is that is right. The groups that donate electron to carbon chain. Actually, you also write one more thing, through resonance. Okay. Right here, through resonance. Through resonance. Okay. Now, in this case, key atom should have lone pairs of electron. Lone pair of electron. There should be at least one lone pair electron. Okay. Done. Now, lone pair of electron, if there is a negative charge also, that means there will be a lone pair. Okay, there will be a lone pair. So I'm writing some questions here. You have to identify which is plus M and which is minus M. Okay. Identify the plus M and minus M group. Yes, done. If you have doubt in any one of them, please let me know first. Are you done with all of them, or is there any doubt? Okay, Abhinav, no doubt. Yes, Abhinav, you done with all? Achha, Sara is also doing. Okay, fine. Do. Yes, done or not done? Still doing, guys? Yes, Umar. Okay. Please let me know if you're done, okay? Reba, are you done with all or you have some doubt? Let me know if you have some doubt. Please don't waste much of time, okay? If you have doubt, please move to the other one. Don't spend much time. Yes, Reba, Rehab, Sarah. Okay. Tell me for the first one, who has done? Plus M or minus M?
Plus M.
Second one, plus M or minus M?
Plus M.
Okay. The third one? Say something now. I know or don't know. Yes, Reba?
Don't
Don't
know,
know.
sir.
Sarah? See, in this case, the key atom will be this carbon atom that is connected to the main chain. Now, this key atom carbon, it has a positive charge, right? It has a positive charge. That is why this will be minus M. We have written that now. If the key atom has a minus positive charge, then also it is going to be minus M. I think we have written here. Key atom has positive charge. Key atom is the atom which is attached to the carbon main chain. Okay, the next, this one,
Minus M.
plus M, minus M, right?
Yes, sir.
Okay, what about this ketone? Ketone will be? What is the functional group here? What is the functional group?
So OC, oxygen carbon ketone.
Ketone. Okay. Now in this, which atom is connected to the carbon chain?
So,
Carbon, right?
carbon.
Carbon is connected. Is carbon connected to an electronegative element? Yes or no? Via multiple bond?
Yes, sir.
So minus M.
Minus M.
Okay. This carboxylic acid?
So again minus M.
Minus M. Okay, what about
Minus
this?
M.
No, plus M. Lone pair, है ना? Key atom has a lone pair, right?
Oh, okay.
Right. Key atom has a lone pair. Okay. What about this? Ether?
There's electronegative. So
नहीं, की एटम क्या है पहले वो बताइए, सीधा इलेक्ट्रोनेगेटिव पे नहीं जाना। की एटम क्या है यहाँ पे? व्हाट इज द की एटम हियर?
So oxygen.
Is the key atom connected to any electronegative element?
Yes, sir.
Yeah, oxygen
No.
is connected to what? Is oxygen connected to any electronegative element?
No, sir.
No. So, but oxygen, now that means it is not minus M. Then we will come to plus M. So for plus M, I just have to see whether it has a lone pair or not. It has lone pair, that is why this will be plus M.
So it's
Got it?
okay, sir.
Good. Now this will be again minus M because carbonyl. Then Cn, again
So
we
why
can
is
see
it
this.
minus M? Why is it?
This one.
Yeah, this one.
Yeah. So what is the? This is our
Yeah, ketone.
group, right? This is our key atom. Key atom is connected to oxygen via multiple bond. That is why minus M. है ना? Yes or no, Mohammed Umar?
Yes, sir.
In this carbon atom,
So it is
nitrile.
amide, right?
No, this is ester, but still, na, I don't have to. This is ester. C double bond O, C double bond O, OCS3. But we need to look at carbon, and then we have to look